Cool, thank you very much, and good afternoon. I'm Qamir Hussain. I work for Ariza and I head up the AI team there. So just, I guess, just as a sort of a, when I was thinking about this talk and I was going back 5 years, so I joined a company called Webio, which got acquired by Ariza this year. When I was thinking about the talk and I was trying to remember back when I joined Webio, thinking about the architectural decisions and the technical decisions that I made. It was just me at the time, and then I built the team out. And I remember, I was thinking about it, and it occurred to me just the anxiety that I had in trying to take a POC into production. And that's kind of the germ, I guess, of this talk, or the theme of this talk, that you can build something in AI, and it's a typical software problem. You do a POC, and then you need to scale it up. You have technical issues, you have product issues, you have all kinds of issues, and you think scaling will be fairly linear. I think in my head, I think like this, that we did a POC in say like a month. In 6 months, we'll have just this amazing AI thing, and sometimes it can take a lot longer. But just as you go through, I guess, building the thing, there's complexities arise that you hadn't thought about. Whether it's language models, whether it's on the team having more mature developers, or whatever happens to be. So that's, there were some of my initial, I guess, anxieties of trying to bring things out. And the reason I titled this talk, Build Robust AI Systems in the Real World, it's really the journey that we went on from having nothing at the start and now having loads of customers, and we were required mainly for our AI and obviously for our business as well. So now we have a very mature AI ecosystem, as I call it, and I'll talk about the journey that we all went on. So yeah, so just very briefly, Webio's it's a company that's about 10 years old. It's a credit and collections software company, so we provide dashboards and integrations for DCAs or debt collection agencies to contact customers who owe them money, who might be going through really, really difficult situations, and the AI helps our customers and helps their customers to deal with really, really difficult situations. A lot of the situations aren't that difficult, but they're clearly very difficult situations. So we care about empathy, we care about how good the AI is and the quality of the work that the AI does. So we were acquired by Ariza this year. We're now part of Ariza Engage. Ariza itself has many more products. It's all in finance, in lending, credit, and so on. And so they see us bringing our AI knowledge into this wider organization to improve the products that they have with AI. So again, I guess we should start with a definition by what I mean by robust artificial intelligence. There are two things that are really important for me when we do any kind of AI work. It's great to have all of these models and all of these techniques, and there's always like another YouTube technical person who'll do this great demo on something, and it'll help, do RAG better or summarize text better. You do like a little POC, a little Hello World example, it works really well, and then when you scale it up with your data or your particular needs, it doesn't work as well, and then you have to do the hard work of actually doing the real work. So for me then, something that's robust in a software sense is something that does the work really, really well, sort of very high level. And as we know, AI language models, they're non-deterministics. So if you're doing GenAI, how do you get it to give you reliable results, for example? If you're doing classification, the job's a little bit simpler, I think, but it still can be very difficult when you're training models and trying to get it to do the inference that you want. So I care about the quality of the work and also the maintainability of the system. So either we need to improve our classification, our summarization, or what we need to do is, we need to scale it up, we need to improve it, and just make sure that we can manage all of that without losing our heads. So that's really what robust artificial intelligence is. I really care about the quality of the work that we do. So the challenge that I had when I started with Webio was One was to understand the credit collections industry. That was all new to me, so this sort of fintech application was very new to me. The other things that I was really concerned about was, again, high quality AI, empathy. So that's empathy for, in this case, the end customer who owes an amount of money, is going through difficult situations. How can we help our customers help them? There's a reputation that debt collection agencies have of being very aggressive and so on. So we wanted to change that using conversational AI as the sort of the term we were using at the time. Again, the two things, the other things I care about, maintainability and scalability. We deal with millions of conversations every month, and the AI needs to be able to handle all of that. So I guess just from an engineering point of view, I think the most important thing in looking at, when you look at an AI system, is to look at the ecosystem. It's not just the model. There are other parts of the system. For me, the AI clearly is really important, and the work that it's going to do is really important, but it's how it talks to a backend that fetches the data. What type of interface do you need? How should the REST endpoints work? Where do they sit? And so on. And for me, the key to this is just good software engineering, which is sort of like a modular, decoupled sort of architecture. So if you're a software engineer, hopefully you'll be aware of these types of terms. And the reason that you want to do that is that you want the system to be adaptable. So like I've been doing AI for quite a while. I'm back doing AI over the last 10 years since deep learning was a big thing. 20 years ago I was doing AI and it was all rule-based NLP. I was doing some neural network work, but it wasn't all that interesting. I was doing really small scale kind of small examples. And back then, when you were developing an NLP system, it was all rule-based, which meant when it worked really well, but when it didn't, you'd have to put in extra rules, so it was very brittle. Since deep learning became a thing, and vector embeddings and so on, and when we could actually train a model to understand language, it totally changed the game. And so every other day, and I'm sure you've seen this, like a new model, a new technique. So if your system is decoupled well enough, you should be able to just introduce a new model, do all of your evaluations, all your testing, and move on from there. And if you can't do that, your job becomes difficult, because like a model, like we've changed our models out a number of times for different tasks, and we got like huge improvements. And if we weren't able to do that easily enough, it just would have obviously caused a lot of problems for us. So it's really about adaptability, as far as I'm concerned. If it's a really modular architecture, things are very loosely coupled, so you can swap things in and out. There is some sort of there is an abstraction that you need to think about. But once you have that in place, I think it's very easy to build better AIs. So that'll cover things like new techniques, new features, any new requirements, any kind of technical changes, and whether you want to swap closed source models for open source models or vice versa. Because you might find, well, look, we've been using ChatGPT, we've been using the open API to do some, say, some summarization work or whatever, but now your company has scaled, that business has scaled, it's becoming very expensive to run. And you might find there's an open source model that you can just stick on AWS, give it a beefy enough server, and that might reduce your costs right down. Again, if it's all decoupled, it's hopefully not too difficult a task to do. So what we did then was we built everything ourselves. We took open source models. Again, this was 5 years ago, so we didn't have ChatGPT. We had other things like Dialogflow and a bunch of other services that we could use for intent detection and so on. And I decided, it was a greenfield project, and I decided we will just take open source models, we'll fine tune them for the tasks that we need. The initial POC was classification, so create a list of intents that we think our customers need, train for that using initially synthetic data, then real data that we anonymize that comes through the system. Train the model, and then put it up as an API endpoint, and the backend can talk to. So as messages come in, they get passed over, excuse me, to the model. The model tries to figure out what it is. Let's say this person is just looking for a payment. They lost their job, so they're looking for a reduction in their next month's payment or whatever. So we can pick out intense entities being names, numbers, customer numbers, all of those kind of things. So that's what we did. And I guess the interesting thing was that at the start, it took longer, I guess, to get a reasonable POC. Shown to customers. Customers will always want some extra features, or the labeling is wrong, or this isn't working as well. We would run it through our sort of QA and evals. We'd have thousands of examples of messages that were payment, for example, and we'd run it through QA, and we'd get like a really high score, and the customer would just put in something and it would just not work. It would think it's something else. So then we went through that journey of continuously fixing things and getting it to a point where the customer was really, really happy. And then, of course, we have other customers that want something entirely different. So that was I guess, the toughest part of getting it out there. We thought we had something that worked well. When customers used it, it didn't work so well. And then we had to iterate on that. So the process then, again, that we have, and the modules, I guess when you think of the components, we train the model on AWS, build the image, it'll deploy all the software that image needs, deploy the model, and bring up the server. So all of those parts are decoupled. So if we needed to use a different model, we could just swap that model out, deploy it, we have an endpoint, and all of a sudden we have 10% better intent recognition or whatever. So again, just to talk very briefly then, just on the decoupled components, I guess, models, the layer, orchestration, the API layer, API backend, the tools, and the deployment pipeline. One of the most important things, I would say the most important thing, is maintaining all of this, and it was the tools that we built. So, like I looked at on the market for sort of enterprise tools that did annotation, managing models, and so on, and they were great, but they did so much. They were also kind of expensive. So we decided to build our own. Initially just started as Python script that would take CSV files, dump them into a database, do whatever we needed. And we built those out, hired a few engineers, and we built those tools out. So they're internal tools only, and they help us manage everything to do with models, deployment, annotation, having custom models for customers and so on. And without that, we'd be absolutely lost. And also, the deployment pipeline is custom. It's quite simple. It's very clean. It's very easy for us to manage. So I guess, there's always this question of why should you use AI for, in a software solution, in a product that you want to bring out. So I talked a little bit about all of the technical things, the components, the models, and how we manage all of that. I think there's a more important question before you start all of that, which is in the industry that you work in, there's all kinds of problems, all kinds of things you could be doing. Why would you use AI? In our case, in fintech and credit collections, that there was a lot of manual processes going on. People are still calling people to say, hey, can we have a chat about this situation? And then the conversation would start. Some DCA, some debt collection agencies did a much better job. They were using SMS and WhatsApp for that. So what Webby had built when I joined was this platform that allowed customers to communicate over SMS, WhatsApp, and so on, to talk to customers who owe debts. And what Webby wanted to do was take that, what they had, and add conversational AI to it, to figure out what was going on, to automate things on the back of it. So what we help with fundamentally is digitizing processes, automating tasks that are really laborious, things that I think humans genuinely hate doing, but they do it anyway because they have to, it's part of your job. So pass that over to AI. And what we did was, what we started off with, and I'll show a couple of examples of some of the things that we started to do later on, was the simple work of just classifying what a conversation's about. And we were able to use small models for that. And the advantage of using small and medium-sized models is that they're cheaper to run, quicker to train, quicker to fine-tune. If you're using large language models, they're far more expensive, take a lot more time to deal with. And of course, they solve bigger problems as well, so there's some trade-offs there. So really what we were doing is we were providing tools for agents, human agents, to perform better, to do their task better, and basically have less stress in their day-to-day job. So, for example, don't know the exact numbers, but let's just say a human agent could deal with 40, 50 conversations a day. The AI can do that in half an hour easily, like in a minute, So it meant that they could scale up, and we've developed it so that there's always a human in the loop. So the AI doesn't directly talk to the customer. We have a screen where a human agent can set up a bot, and a bot is just some automation to say it might be identification and verification, so ID and V, where somebody might send a message, say, yeah, sorry, can I pay £50 next week? And a message will go out to say, sure, no problem, but before we discuss your account, can we get your name and phone number, please? And the AI can pick that up and just verify that it's Qamir Hussain that's talking. He's provided the details that you've asked for. So our customers, they can configure all of that, and they can have guardrails put in, so it's a very limited scope in terms of what the AI can measure, what it can do, and so on. And it means those sort of laborious tasks are sort of taken care of by the AI. So just in terms of then, I guess, some other hard issues that we have to deal with outside of technical, just sort of pure business issues, that we're very tightly regulated in terms of where the data sits, where the data can go, how the data is processed, and so on. So when we train our models, we can't have any PII information, even though it's very, very private. So we've built tools that remove all of that. So when we look at real conversations, we remove all names, numbers, addresses. We'll mask them or just come up with sort of generic, publicly available sort of addresses or postcodes or whatever if we need to. We don't always need that sort of information to train the models. We have different models that do different things, so we don't always need it, but when we do, we use like generic ones. And so I think the work that we did, which is now Arise Engage, I think it's a really good case study in terms of first of all, building something from scratch that you control, like all of the models, all the pipelines, and so on. But also, I think it's a great case study in terms of sort of sensitive business issues and data issues that you get in fintech, and how we solve those. And solving some of those wasn't a technical thing. Very often it was a product thing. Or it's just sort of out of the box thinking, I guess, to say, look, we actually strictly don't really need that, so we can kind of move that over to the side, and that'll solve our problems. And the whole point is, for me, I think, is, I think good software and good solutions help everybody in the pipeline. So our end customers, our immediate customers, obviously ourselves, we're a business at the end of the day, and our customers are businesses, and then we have their customers who are, there's a reason that they're behind on their bills or whatever. So, if we keep them happy as we can, then everybody's happy in the loop. Just finally on this, we deal with a lot of sensitive conversations, and really what we do is we set clear boundaries on, we set clear boundaries on what the AI can do, and that took a lot longer than I'd care to admit in terms of what the AI should and shouldn't do. And this is where the POCs and the continuous sort of communication with the customers really helped with. So there's certain things that we can just avoid, other things that we really need to have a good handle on. So again, AI and automation is really the sort of the key to it all. There's lots, again, that we could do, and we were doing with the AI. But if we couldn't automate something off the back of that, it probably wasn't a good feature from the AI point of view. This is something that I kept saying, again, in Webio when I started, was when the AI does something to something afterwards that needs to happen. So you automate something, you might, vulnerable customers might automatically get put into a queue where a human agent can talk to them. Sometimes it's somebody just wants to pay a bill. They forgot. Say, look, can I pay next week? And you can just set up an automation to say, if somebody wants to make a payment, send them a link on the date and just confirm that they can make that payment. So you just have a simple thing to say, that's great, thank you. Can we will send you a link for £50 next week, just say yes or no or something, just to make sure. So the customer knows exactly what's happening. Thousands of these payments are automated. It saves a huge amount of time for our customers. And so that whole thing of like AI does something, there's something afterwards that needs to happen to kind of complete the loop. It's not just classifying something. Well, you've classified something, now what? And the now what is automation of the next best action, as I call it. And so, again, just I think from my point of view, I think really the most important thing is like we're actually building product. What AI is a huge and a very important tool of it. I think it's the user experience of the AI is really how you should think about it. What do you want the AI to do? Does it solve something that can't be done in any other way? If it can be done another way, just do it the other way. It's easier, you know. So product UX, I think, is really, really important. Again, just as I mentioned earlier on, I was anxious just to roll something out as soon as possible. I think as developers and as product people, as designers, you know, you just want to see the work that you're doing and the team's doing just out there. But it always takes longer than you think. And the most important thing, again, for me, is the quality of the work. And that's always the main focus. So working with customers, getting the feedback, that always takes longer. Somebody's sick for a couple of weeks, so you can't roll out a particular feature because there's a couple of issues and you need somebody to sign off, and you know, we can't actually solve these features right now, so can we do it in a couple of weeks' time or whatever, or reduce or increase what the intents do, change labeling, and so on. So I guess just to sort of wrap up sort of my experience, I guess, over the last 5 years, and my experience, I guess, being a software engineer and doing AI different ways over the years, is for me, it's really about good engineering principles. I think that's the key to good, sort of solid, robust AI. Decoupling, having tests, having a really, really good test suite, building tools that solve your problems as well, not just the problems of your customers. For us, it meant that we had a longer lead time before we could show things, or before we had a pipeline that was efficient in terms of the workload that we had to do in the data science side or the deployment side. We were a small team, it took a lot longer. But once it was there, maintaining it was really, really simple. If we need to add a feature or fix an issue, it was really, really simple. And it worked really well because we had the source code. If we didn't like something, we could tackle it right away, regardless of how long it might have taken to fix it. So good engineering principles, flexible architecture, so you can add models, features, all of that kind of stuff as easily as possible. QA and data is what we do most of the time. You know, we're lucky we can take models from Hugging Face, we can go look at a Roberta model, do an evaluation, then we have millions of conversations that we can fire off it and compare its output versus the one that we're currently using as an example, and take it from there. So QA, data, absolutely the most important thing, and think of software engineering principles. So given that Halloween's around the corner, I found this slide last night and I thought, this will work. Don't be afraid to build your own AI. I know Claude is amazing, ChatGPT is amazing, but there's also amazing open source models and tooling out there. Again, you'll have to learn a little bit, but I think that actually helps in the final, the final thing that the final product that you're trying to deliver, because you'll understand things at a deeper level, and that's always a good thing as far as I'm concerned. And then again, think of ecosystems, trade-offs. You know, there's more planning up front. You'll do a POC, it'll look great, and then as you scale up, you're like, we need all of these other things. It's going to be way more complicated to build than we thought. You control everything, and I think it's also cheaper. It'll be cheaper. It's more expensive. I got these slides wrong a little bit. So I think it's going to be more expensive in the short term. When you get to MVP, it's probably more expensive if you went for Claude to do a POC, because it'll have a lot of things for you, or one of the closed source models. Oh, sorry, yeah, I see what I did there. I was talking about, so the closed source will be cheap in the short term, and again, depending on the application, it could be more expensive in the long term. And then the upside of building your own then is there's more longer term benefits. You control everything. If you want to do GenAI, as we've done, we've added GenAI over the last 18 months. We took the same process. We looked at a few large models, and one of the first tasks that we needed was summarizing conversations that smaller models just couldn't do. So long-term benefits, also from a compliance point of view, you can stand over everything that happens if you've built your own ecosystem. You know exactly where things are, you know where the data is, you can build all of your explainable AI, whatever detail you need in that. You end up becoming an expert in multimodal AI. So you'll use a small model for classification, quick, easy. You might use a medium size for other aspects like maybe OCR, stuff like that, and large language models for the truly complex language tasks or whatever. And each one of these is a specialist in something. And all you need, in quotes, all you need is some coordination between them, and you've just got this brilliant system. And that's what we have now. We've got a very mature system that works really, really well. So again, just a couple of thoughts on costs and so on. So I'll just run through a couple of quick examples. Classification, these are the types of messages that we deal with. You know, lost my job, I'm feeling stressed, so that will get classified as a vulnerability. Customers will have rules set up to say, if something's vulnerable, just add it to a queue, and we'll have a human agent deal with them directly rather than, you don't want a chatbot dealing with stuff like that. For anything else, payments, send them an automation when the time is right. And out of these, we can pick out the names, intents, and so on. And just in terms of a GenAI example, this is just like an example of a longer conversation. And Melinda Gates here, she's behind on her bills. And so what she wants to do is, rather than just pay something, she wants to redo her plan so it's more affordable for her. And if an agent is looking at this, and again, remember, a small level of conversations is fine. When it goes to thousands, it's really difficult. So it can be really difficult to deal with, and they get overwhelmed very easily. So one of the features that we worked on was to summarize that conversation into 3 bullet points. So if an agent is looking at the conversation, they can just click on the summarize button, and they've got 3 bullet points, and they have an overview of the most important things. So just to wrap up then, think in AI ecosystems, all the components that make it up, how do they connect? Are they decoupled cleanly? Think about things like model configuration as well, because I know very often if you're working with an LLM, you'll have your configuration inside your Python code and stuff like that. If you're going to move over to another model, you'll have to abstract that at some point. So just think of abstracting everything and not have hard-coded things in. So model configuration and system prompts as well. Think about those, decoupling. And that's the talk. Thank you very much.